I'm going to open this video by saying this is not required watching. I'll go over this example in class. But if you're feeling like, I think I'm understanding, but I want to be sure and I want to see one example, feel free to watch this. Let's do one that has a messed up period, x over 4. What we want to keep in mind is that for tangent functions, the normal, like I always go with the asymptotes. That's what I always like to go for. I like to figure out where they're at. So I need to bring to the table that the tangent asymptotes typically are at negative pi over, like for the standard one is negative pi over 2, pi over 2. And if I'm doing 2 full periods, I'll go to 3 pi over 2. So I want to walk in knowing that idea. Now I got to figure out what values of x would make me be taking the tangent of these undefined values so I can put my asymptotes there. So tangent of negative pi over 2 is going to happen when x over 4 equals negative pi over 2. Tangent of pi over 2 will happen when x over 4 equals pi over 2. And tangent of 3 pi over 2 will happen when x over 4 is equal to 3 pi over 2. And some pretty straightforward algebra can get us that this will happen when x equals negative 2 pi, when x equals positive 2 pi, and let's see, this one I can't do in my head as well. X equals 6 pi. So I'm going to go ahead and put in an asymptote of negative 2 pi, ding, 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 positive 2 pi, and 6 pi. Now you might be saying, Mr. Depsic, yes? Why did you find the asymptotes and not the zeros? I found the asymptotes and not the zeros because I need to approach those asymptotes and I want to have a solid understanding of where they're at. And so I'm going to always start by finding those asymptotes, looking at where these things are undefined. I know that tangent is the one that's got the pi over 2's at the asymptotes. I know these halfway points are where it's going to equal 0. So halfway between here and here, of course, is just 0, and halfway between these guys is 4 pi. Dude, I'm almost done with this problem. Because at this point, I just need to know what that basic shape of tangent is. And tangent is the one that looks like x cubed. So, ka-ding, ka-ding. That's it. I'm done. I did it. Now you might be wondering, Mr. Depsic, what happens if there's a 5 in front of here? I'm not going to worry about that with you guys. I really do. It stretches the graph out. But this graph's range is already from negative infinity to infinity, so the stretch is not that interesting. I mean, if you really are dying to know, here's what I'll tell you. The halfway point of the halfway points is the point that usually corresponds to pi over 4. And the tangent of pi over 4 is 1. So I would know that the halfway point of this halfway point of pi would be that 1 stretched out by 5. So this would be the point pi comma 5. I don't care. I don't want you to care. It's not important. So if you see a stretch factor on any tangent or cotangent, don't stress out about it. Pretend it's not there. I just care if you know where the asymptotes and the zeros are in the general shape. That's all that matters for tangent and cotangent. For secant I care. For cosecant I care. For cosine and sine I care. But for tangent and cotangent, because it's going to hit all the y values forever,